Okay. So we should be done with our quiz. That quiz looked pretty good. There weren't a ton of questions in the office hour, but I was asked if I was going to post the office hour notes, and I do plan to do that. So I apologize that I didn't yesterday. I set them aside and I forgot to scan them. I think I might have had some also from Monday that I still was saving. So I'm going to look real quick, but I just emailed them to myself, so I'm going to upload them after class. Did we have questions from the homework? Any lingering questions?
Yeah, I have a question.
Okay.
I just gotta find the question first.
Sure. No problem.
Okay, so for number 16, when you're finding the derivative of x e to the x,
yes.
How do you get it?
Did I do this one in the office hour? I did this one in the office hour. So the derivative in the denominator is using the product rule. So f prime g plus ft prime. So if you consider this whole function to be the whole denominator to be a separate function, then its derivative is f prime, which is the derivative of x, times g plus f, and then g prime, the derivative of e to the x is still e to the x.
Okay, thank you. Yeah, I didn't consider it as a separate function.
Yeah, you kind of have to, yeah, because I mean, since you're going to need to take g prime when you take the quotient rule, you just need to take the derivative of the denominator applying the product rule. Yeah, I'll post that. Okay, so one thing I did want to say about the homework was I don't want to get all worked up about it because I don't know what's happening. I have a distinct memory of taking off those last two word problems. I specifically clicked the little garbage can next to them. I took off like 5 or 6 questions because I've taught this class with this book on WebAssign before. So I have assignments that I already have used before. So when I assign them for you guys, I edit them, I go and redo the dates, but I go through and I kind of try to think about, it's weird how I remember what caused students problems the last time. And if I thought they were unreasonable, then I would remove them from the assignment. It's possible that I'm not clicking save and I'm just clicking schedule, and then it's not saving my changes and scheduling them. So there were 2 really long word problems at the end that I just didn't really feel had a lot of value to them. And I tried to remove them from the assignment, thought I did, and they were still on there. And I was getting questions about them in the office hour. If you did those questions, you still got the credit for them on WebAssign, and it'll still show up. It's just that when I grade it for you, it's going to be taken out of fewer points because those questions were like 9 or 10 points apiece. They were huge. So if you notice, like that actually happened last week when I took off those 2 questions. Some of you had already done them, and you did end up still getting graded with points for those on WebAssign. And then when I entered your grades in D2L, even though the max was technically out of 36, some of you got 39. So I just set that assignment to exceed the max. So if you did those questions already, you'll get the points for them. Otherwise, I took them off just because I'm not going to test you on anything like that, and I didn't think there was a lot of value. And like I said, I intended to take them off. This problem, I swear I intended to take this one off. It's fine. It's not that crazy of a problem, but I went through it, hit the little garbage can, it went away. When I was done with the assignment, it said it had 29 questions on it. And then when I saw it at the beginning of class today, it said it had 35 questions on it. So I'm just going to have to assign them and then preview them and verify that my changes were made, because clearly it's not happening, which is very odd. Anyway, so there's that. So my apologies. I'll have to just do a lot of double checking when it comes to this WebAssign business. Anything else from the homework that's bothering anybody? So your test is on Monday. You know what Monday's date is? Today, Thursday, add 4 days, 28th. And guys, we're almost into July here. This class is going to be over before you know it. Your test on Monday is going to cover 2.1 through 2.5. I'm covering 2.5 tonight. It's actually pretty short. I know I can take any short section and make it long, right? But I only have 7 examples to show you. So when we finish with 2.5 tonight, I will be done with you. And then you will be on your merry way to get ready for your test. Oh, I have to remember to put up a review assignment for you on WebAssign. So I'm going to add on my sticky note to add a chapter 2 review homework, which will be optional. But a lot of you guys did it last time to help prepare for the exam. And I did get some WebAssign questions on it. So I'll put that up for you just as, you know, some extra review. The nice thing I will say about this book and WebAssign is that the reviews are actually different questions, whereas my math lab pulls reviews from chapter questions. So it might be a question that you've already seen before on my math lab, but WebAssign actually correlates it to the actual book review problem. So that's kind of nice. So I'm going to do that. Put my sticky note down here. Your test will be Monday. I'm going to start checking everybody's viewing a little bit earlier, everybody's viewing angles and I should say workspaces. But whatever you had last time, if I okayed that, just do that again and you should be good to go. Let's see, 2.5 is about derivatives of trig functions. Nothing too crazy though. I know last time we did trig functions, it was with limits and it gave everybody a really hard time. The derivatives are pretty straightforward because they're all just rules. And there aren't even that many rules. Okay, for next week, remember that I said that you will have an asynchronous lesson on 3.1 this weekend. However, I mean, whether you watch it this weekend or whether you watch it Monday night, it's up to you. I'm not going to have the stuff due on Monday. That would be kind of silly because you're being tested over 2.1 through 2.5 and you have a test Monday. So for your 3.1 stuff, I'm going to have that homework due on Wednesday, which would be the 30th. So I don't want you to feel forced to do asynchronous work over the weekend if you're studying for your exam. Now, it's only 5 sections for your exam. It's not the end of the world. And 3.1 is still derivatives. But if you feel like you're going to get mixed up and you're very focused on 2.1 through 2.5, that's fine. You don't even have to look at the asynchronous stuff until Monday night if you don't want to. But I'll have that due on Wednesday. I mean, technically, you could look at it Wednesday afternoon. I wouldn't wait that long, though, because it's going to take you a while to do the homework. It's chain rule. It's not like the easiest thing in the world. It's not the hardest thing in the world, but it's definitely something you need to practice. And I'll expect that you'll have questions when you come to class on Wednesday. Okay, so I'll see you Monday for your test. You have Tuesday off. So if you want to do the async stuff Tuesday instead of the weekend, that's fine. If you want to bang it out this weekend and be done with it, that's fine too. I'm going to post it so that it's ready for you after class tonight. I'll send an email. I'll make sure that the email is explaining all this again so it's written down so that you know exactly what you have to do when. So if you want to do it by Monday, fine. But I'm going to set it to be due Wednesday, 6:30 at 6 p.m. And you won't have a quiz Wednesday because we don't do quizzes Wednesday, but you'll have a quiz on Thursday, which is July 1st. Over 3.1 and whatever I cover in class on Wednesday. Okay, so the asynchronous stuff will cover 3.1. Do it this weekend if you want. Do it early next week if you want. Doesn't matter. It'll be due Wednesday. So that's just sort of an exception to normal operating procedure. Is there anything else I wanted to say about that? I don't think so. questions about the schedule heading into next week? Okay. Excellent. I thought about updating the syllabus just to reflect any changes, but I mean, I don't want to just keep changing it all the time, but I mean, I could just move the tentative exam date just so it's in there, I guess, if you find that that would be helpful. Also add chapter 2 review homework and then post asynchronous 3.1. Sure. Do those things. Wonderful. So let's talk about trig derivatives. Like I said, it's a pretty short section. 2.5. The derivative of the trigonometric functions, I should say the derivatives, the trig functions. Oh, and by the way, anything I assigned tonight from 2.5 will still be due Monday. So 2.5 homework due Monday, 6/28. And then of course, whatever I assigned yesterday should be due tomorrow. Nothing has changed there. Okay. So I'm going to give you a theorem, but it's basically just 6 trig derivatives because we have 6 trig functions. So let's see. The derivative of sine x with respect to x is cosine x. The derivative of cosine x with respect to x is negative sine x. The only major thing you're going to have to remember there is which one of those is negative. So the derivative of sine x is cosine x. The derivative of cosine is negative sine. What you're going to find here is there's going to be a pattern where any function that starts with co is going to have a negative derivative. Any function that does not start with co will have a positive derivative. For tangent, the derivative with respect to x is the secant squared of x. You're also going to find that the cofunction's derivative is going to be related to the derivative of the original function. So if the derivative of sine was cosine and the derivative of tangent is secant, well, the derivative of cotangent is going to be negative because it's a cofunction. And then instead of secant, it will be cosecant squared x. So in a lot of cases, as long as you remember the function on the left's derivative, you'll be able to easily get the function on the right's derivative. And then for the secant of x, the derivative of the secant of x is the secant of x times the tangent of x. Just say secant x, tangent x. And then as you can imagine, for the derivative of the cosecant of x, you're taking negative cosecant x cotangent x. So you can see that pattern, but these will all be in your notes, and the test is open note anyway. So those should be pretty straightforward for you there. Just highlight them. Do whatever you need to do to make these stand out to you. So those are the derivatives we're going to be working with today. And just like with a normal derivative, if your function is not already in a form where you can easily take this derivative, then you're going to have to put it into that form. And of course, we're going to mix this in with product and quotient rules. So example 1, I really only have 3 examples, but example 1 has like parts A through E. Find the derivative. So the first function, and I've taken to calling these h of x just because if we need to use the product or quotient rule, I don't want the f and g to be confused with the function names. H of x is 4x cubed times the cosine of x. So this is a classic example of when you would have to use the product rule, and there's no way around it. You're taking the product of a polynomial function and a trig function. So you're going to need to use the product rule. In order to use the product rule, you'll probably want to label the pieces of your function h. The first factor will be f, and the second one will be g. Technically, it doesn't matter which one's which. By the way, notice how the polynomial is written in front of the trig function. It doesn't have to be the case, but anytime you see these mixed together, that's the general convention for writing these. So when you're writing your own mixtures of functions, usually we put the polynomial first. And part of the reason for that is because if you put the polynomial behind the trig function, it kind of looks weird. Like, I don't even know how you would do that, but I guess it would look kind of like this. And then sometimes students think that they can take this 4x cubed and multiply it in, and they can say that this is the cosine of 4x to the fourth. And maybe you think that's crazy and weird. I've seen it happen so many times. I can't even explain to you how many times that happens. This is not the same. You cannot do this. This is a big no. So part of the reason we try to write the polynomial in front of the trig function is so that there isn't confusion with that. We don't want to end up accidentally multiplying this polynomial into the trig angle. So just wanted to make sure to mention that, that you cannot do that. So you can technically write it this way, but just be careful with your parentheses. All right, so we're going to take f prime g plus fg prime. Well, if f is 4x cubed, then f prime is 12x squared. And then if g is the cosine of x, then g prime is the negative sine of x. All the derivatives for functions that start with co are negative. So to take the derivative of h, we're going to take f prime g, so 12x squared times the cosine of x is our f prime g, and then plus f, and then g prime. Now, if you're looking at this in advance and you're noticing that g prime is negative and you want to just go ahead and write it with a minus so you don't have to rewrite it, fine, no big deal. A lot of us don't have the foresight to do that. Half the time, I don't even think to do that. But I would technically say this isn't really simplified, having plus a negative. So just rewrite this so that you just have a minus. You'll have 12x squared cosine x minus 4x cubed sine x. And factor if you want to. Don't factor if you don't want to. Leave it the way it is. Might as well do less work. Are there questions on A? So we'll do another one. B is h of x equals 4x squared sine x minus 2x cosine x. So you're going to need to notice here that you're going to need to use the product rule 2 times because each one of these terms has a product in it. So it's kind of up to you how you want to label this. But if you want to just take the derivative below it, that's fine. We're going to be using f and g twice. The notation is going to look terrible, but if you want to just keep calling them f and g in both parts, that's fine. Just do that. I don't think students have an issue with the notation the way the teachers do. It doesn't drive you guys crazy like it drives us crazy. All right, so f prime would be 8x and g prime would be the cosine of x. And then for the second term, if you let these guys be your f and g, then you'd have f prime is 2 and g prime would be negative sine x. Just make sure you're looking at the right set of information as you're working through your derivative. All right, so first let's take the derivative of the first term, which is 4x squared sine x. So we're going to take f prime g plus f g prime now we're going to subtract because remember we have this minus sign here. And I want to be really careful about this because I know I'm going to end up having more than one term behind the minus sign. So I'm going to put parentheses around this. This is one of the most common errors I see with this type of problem is people don't distribute that minus sign. And I know it doesn't seem like a big deal, but it will really affect the way that your answer is simplified. So let's work inside the parentheses and we'll just take f prime. Now we're following this information. G plus f g prime. So we're going to distribute the negative sign and simplify. Are there any questions right here? So the 8x sine x can stay right where it is, and the 4x squared cosine x can stay. So we'll have minus 2 cosine x, and then be careful because this last term is actually negative. So when you distribute the minus sign into the negative, you're actually going to get a positive term there. So we'll have a positive 2x sine x. And then we're going to go through and see if there are any like terms that we can combine. And in this case, we have 2 terms that have an x sine x on them. So we can go ahead and add those together. We can consider those like terms. I'm going to write mine in descending order because I'm pedantic. We have 4x squared cosine x plus the 8 and the 2 give us 10x sine x and then minus 2 cosine x. That is your final answer. So you can see now that even though these derivatives themselves are not too crazy, when you start to add more of them in one problem, it can get a little bit confusing because you have to keep track of everything and make sure that everything's accounted for and all your negative signs are where they're supposed to be, so on and so forth. My focus is off. Okay, questions on B. I have a note to self here, and I think this popped up last time because I wanted to do an example like this, or I realized later that I should have included one and didn't. I think that's why the note to self is here. So I'm going to I'm really glad I made this note to self. We're going to do this one. Oh, actually, you know what? This is not, my note to self wasn't actually that good. Do you know why? The function that I suggested was sine x times cosecant x. Those two are reciprocals. That would have been a not very interesting function. Let's change it to sine x times the cotangent of x. Sure, why not? We'll see what happens. Okay, so we're going to take f and g. We're going to need the product rule here because we're multiplying the sine times the cotangent. Now, oh gosh, you know what I just realized? The cotangent is the cosine over the sine. This really just simplifies the cosine. Let's call it secant. Sorry, guys. I swear we're going to get it together. I just made this up on the fly, so you'll have to excuse me. Let's do sine x times secant x. It's probably what I should have gone for anyway. Sine x times secant x. We don't want this to simplify to something really easy because then you would be wondering, like, why did she not simplify this? She could have saved herself a lot of work. And then it would totally defeat the purpose of using the product rule. Okay, this one is good. All right. Let the sine be f and let the secant be g. So these, again, we're multiplying these two together. If you can simplify it right away, do so. Like if you had sine times cosecant, well, a function multiplied by its reciprocal is just 1. If you had sine times the cotangent, well, simplify that to a cosine. This one you can't really simplify, so I would let it be. Oh, we need to go ahead and write our derivatives down. Okay, so f prime, the derivative of sine x is cosine x, and the derivative of the secant of x is secant x times tangent x. And we'll see what happens here. All right, so we're going to take f prime g, so cosine of x, times the secant of x. And if you're wondering, like, could this be a place where we would simplify later? Yes, absolutely. F prime g plus f times g prime. Now, simplify where it's reasonable. If there's something that's obvious to you, you should do it. Like, for instance, a function multiplied by its reciprocal. That's going to be 1, because remember that the secant is 1 over the cosine. So we can simplify that as 1. If nothing is sticking out to you in the second term, that's fine. You can probably leave it alone. Like when I'm thinking about what's happening to this function, I'm maybe thinking like, okay, well, I have sine x. The secant of x is 1 over the cosine of x. The tangent of x is sine x over cosine x. I mean, really, as far as this guy is concerned, there's not a whole lot you can do. I mean, yeah, you could write it as sine squared x over cosine squared x, but why? You don't have to do all this work just to get everything written in terms of sines and cosines. And I know that we've sort of been doing that since trig, where we prefer for everything to be written in sines and cosines. But I mean, if it doesn't make sense, if there's no way to really simplify it, then just let it be. This I would expect to be obvious, cosine x times secant x. That is something where I would definitely expect you to simplify that to 1. So, you know, use your head there. Think about what would make sense logically. Glad we did that one. Does anyone have a question on C? All right, let's do one then that uses the quotient rule. We'll let h of x be 1 minus the cosine of x divided by sine of x. Now, if you want, you could really rewrite this by splitting up the denominator, and you could put this in terms of two simpler functions if you wanted to do so. If you want, we'll do it both ways, and you can see that the answer is going to be the same. The amount of work is probably pretty similar. But let's do it first using the quotient rule, and then I'll show you how to split it up and then use the product rule, and then you'll get the same thing. So we'll have f and g. F prime is going to be 0 minus, well, the derivative of cosine of x is negative sine x. So f prime is really just positive sine x. G prime is cosine x. So let's use the quotient rule. We'll take f prime g, so sine of x times the sine of x, f prime g, minus f times g prime. Divided by g squared. And then we'll simplify. So we can rewrite this as sine squared x, and then we're going to distribute not only the negative sign into the parentheses, but we're also going to distribute this cosine into the parentheses. We're going to work this one backwards. You can do this in as many steps as you need, but I have a negative 1 times cosine x, which is minus cosine x. And then a negative times a negative gives me a positive cosine squared x. Now, part of the reason I wanted to do this one using the quotient rule, instead of simplifying it to a different variation and using the product rule, is because I want to remind you of how you're going to be using your Pythagorean identities along with any other trig identities that you can use. So recall that sine squared x plus cosine squared x equals 1. If there's something very obvious in your answer, like sine squared x plus cosine squared x, and you can simplify that, you should do so. Again, I'm talking about things that I know what I think should be obvious might not be what you find obvious. But a sine squared x plus cosine squared x, that should be something that's jumping out at you as like, this can be really simplified. If those appear, those two terms appear, just turn them into a 1. The minus cosine x stays right where it is, and the denominator is unchanged. Now remember, in the numerator, in order to cancel, or in order to turn 1 minus cosine x into sine squared x, it would have had to have been 1 minus cosine squared x. So you can't actually simplify this to a sine x. I've had students try to do stuff like that before. What I mean by that is 1 minus cosine squared x equals sine squared x. They sometimes try to say that 1 minus cosine x equals sine x, but that's not true. They both would have to be squared for that to work. So you can't simplify this to sine x and cancel. This would be as simplified as this one would get. And of course, there are any number of crazy things you could do by splitting up the fraction, using the LCD and rewriting it. But honestly, this is fine. As long as you've simplified that quantity, this is good. I did want to show you this using an alternate method, though, because I want you to see how different your answer could possibly look, and that doesn't mean that it's wrong. What I mean by that is, let's say that we still have that original function h. By the way, look at how similar that derivative is to the original expression. It's a total coincidence. Let's say you decided to rewrite this first as 1 over sine x minus cosine x over sine x, just by using the common denominator and distributing it to your terms. Then you could rewrite your function as the cosecant of x minus the cotangent of x. And part of the reason I like to do this too is just to sort of get the juices flowing as far as trig identities. So you could rewrite your function h of x like this. Now that looks completely different, and that means your derivative is going to be completely different. Also notice that this particular derivative doesn't require the quotient rule, and it doesn't require the product rule. So when you go to take h prime of x, you actually have less work to do in this instance. The derivative of the cosecant, well, if you know the derivative of secant is secant tangent, the derivative of cosecant is negative cosecant cotangent. And then the derivative of cotangent, well, if you know the derivative of secant, or I'm sorry, tangent is secant squared, then you'll have negative cosecant squared of x. So again, just taking you back to those derivatives for cosecant and cotangent. And then you just have to simplify this, which is no big deal. So you would just say this is negative cosecant x, cotangent x plus cosecant squared x, and you'd be done. And if you tried to factor out a cosecant x, you can, but it's not going to get you anything more interesting. You would still just end up with a cotangent plus a cosecant. Nothing you can do there. Now, this answer looks vastly different than the one that you obtained using the quotient rule. Technically, if you want, you could go through identities and make them match. That's part of why you did verifying in trig, just because different answer forms or different answers can take on very different forms, yet be the exact same thing. So these two are equivalent. I just don't want you to think like, oh, well, I did it this way and I got this answer and it looks completely different, therefore it must be wrong. It doesn't mean your answer is wrong. I mean, it's possible that you did something wrong and ended up with something crazy. But your answer can be different or look different and actually not be different when it comes to trig functions. So just wanted you to keep that in mind. If you want, we'll have extra time at the end. You can, I mean, actually, this one's really easy to turn into your original. I'll just do it real quick because the verify is good for you. If you turn the cosecant into -1 over sine x, and then if you turn the cotangent into cosine x over sine x, and then if you turn the cosecant squared into 1 over sine squared x, then you can actually rewrite this as 1 minus cosine x over sine squared x. And you find that you have the exact same derivative as you got up here. So that one's not too crazy to verify. Okay. When I put that trig cheat sheet up for you guys on D2L, and some of you I know printed it out and used it on your last test, feel free to do that. But there are 2 other Pythagorean identities that you might find useful if you want to write them down. One of them was tan squared x plus 1 is cotangent squared x. No, secant squared. Yes, secant squared. Sorry. The tangent and the secant. What am I doing with cotangent? Tan squared plus 1 is secant squared x. And then the cotangent squared x plus 1 is the cosecant squared of x. That's right. So those are in a slightly different form. You can manipulate them however you need to manipulate them in order to use them to simplify your expressions. I'm just verifying that those are indeed on your sheet. Yes, they are. Pythagorean identities. It's like halfway down your trig cheat sheet. Where are you guys? There you are. Okay, questions on that example? I know that was a lot of information. Okay. That was D. We will do E. H of x is 2x minus 3x cotangent x. For the first term, you're not going to need a product rule. For the second term, you will. You'll have f and g, where f prime is 3, and g prime, the derivative of cotangent, is negative cosecant squared x. Half the reason I do this example is just to give you more practice with distributing that negative sign into your terms. The derivative of 2x is 2. Then you'll have minus. Don't forget your parentheses. Work on your product rule inside the parentheses and then deal with simplifying it. Don't try to take everything on at once. F prime g plus f g prime. And I know you guys just learned this yesterday, and technically your homework's not even due till tomorrow, so you haven't done a ton of product rule yet. But everything comes at you so quickly in the summer. I'm going to simplify this before I do. Are there questions here? So we have 2 minus 3 cotangent x. Your last term is actually negative inside the parentheses, so a minus a negative gives you a positive 3x cosecant squared x. And this one is done. I know I only said I had through E for you, but that's because I added that example. So I have another one for you. But it's all good. My kids and I are reading all these Pete the Cat books all the time. And that may be after you guys' time. I don't know when Pete the Cat came around. But it was written by like these hippies. So they're always saying things like groovy and it's all good. So my 4-year-old is always like, whatever, it's all good. It's just what we say all the time now.
I have a question.
Tell me. Ask me.
When you were doing the like h prime of an x, you put 3 like plus 3x. Isn't it supposed to be 2x?
F prime. So this is.
Well, we're not taking the 2 from the beginning. That's
right.
fine.
Yeah. So this derivative. This is the derivative of 2x.
Oh, okay.
The rest of it, yeah, I should have labeled it. So f prime g f g prime.
Okay.
Clear?
Mhm. Yep.
Cool. Thanks for asking. Other questions here? Okay, so the last one in this find the derivative example is x squared cosecant x divided by e to the x. And maybe it's good that I left that product quotient rule in your homework, even if I didn't intend to, because this is going to be the same idea. We haven't mixed an exponential yet with a trig function, so we're going to do that here. But also, it's important to note that not only are you going to have to use the quotient rule, but you're going to have to use the product rule when you take the derivative of f. Now, if you're wondering, like, maybe I could move the e to the x up and avoid the quotient rule and only use product rule, I would not do that, because if you move the e to the x up as e to the negative x, then you'll have a product with 3 different functions and you're going to have a big mess on your hands. If I were you, I'd leave it as a quotient. You don't want to have to deal with more than one product at a time if you don't have to. So I guess I only bring that up because I saw that WebAssign left an answer as e to the negative x and moved it into the numerator. How it got there at what point I couldn't tell you, but I would not take 3 functions and multiply them together. It'd be a huge mess. I mean, it's doable, but I wouldn't do it. Okay, so we've got f and g. Well, g prime is no big deal, e to the x. F prime is going to use the product rule. And when you do that, you're going to think about x squared as f and cosecant x as g. So we're going to take f prime g plus f, and the derivative of cosecant is negative cosecant x cotangent x. So if that's bothering you with the plus and negative, you can always rewrite that. Trying to figure out the best placement for that so that it doesn't look really confusing. I'm going to just put it above. Minus x squared cosecant x cotangent x. Okay. Before I begin, are there questions on the components or why we have these components at all, why we need them? Okay. So we're going to use the quotient rule now. We're going to take f prime g minus f g prime and divide it by g squared. And here are your components, f prime, g, f, and g prime. So f prime is going to be 2x cosecant x minus x squared cosecant x cotangent x. That's f prime. And then we have g. I would put parentheses around f prime if I were you, because you want to make sure that g is multiplied by that entire quantity and that it's not just being multiplied by that second term. So that's f prime g minus f, which is your numerator, and then times g prime. And again, I'm so weary anytime I put the trig function in front of another function that something's going to get screwed up. That's why I put parentheses around that. You don't have to have them, but I think it helps for clarity. Divided by g squared. Now, I was saying in the office hour that if you want to write g squared as just e to the x times e to the x, that's fine. Because notice that you could actually factor out that e to the x right here and then get rid of it. I don't even care if you show me the factoring. If you just notice that, okay, I have this term, that term, and each one of them has an e to the x, and you just show me cancel, 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 that's fine. I'm going to show it factored just because I'm the teacher and I want to make sure everybody sees where it's coming from. So I'm going to take this e to the x and factor it out. And then what that's going to leave me with is 2x cosecant x minus x squared cosecant x cotangent x minus x squared cosecant x divided by e to the x times e to the x. Let you take that in for a minute. Soak it up. Okay. Questions before I cancel? So get rid of an e to the x now that it's factored. And you can simplify your answer. Now, notice that you can't actually combine any of these terms. X cosecant x and x squared cosecant x, not the same thing. And the middle term has a cotangent in it. I mean, if you wanted to, you could factor a cosecant out of the whole thing, but when in doubt, just leave it. Each term does have a cosecant. I don't know, I'll leave that up to you if you want to do that. My advice to students is always, if you don't have to factor, don't do it. Just leave it like that. You do have to cancel out the e to the x's though, otherwise it's not considered simplified. Okay. I want to go through an example where we look for the equation of a tangent line, because anytime we do something like that with a trig function, students have a harder time with it. And then I wanted to go through an example where we're looking for places where there might be a horizontal tangent line, because that's another thing that can be tricky for trig problems. All right. Any lingering questions on F? Okay. And if there's something where you're not quite sure, but you think you might have a question on it, circle it or highlight it or something, and then catch me at the end real quick and say, about that one, I was not sure about such and such. And that's not a big deal. Example 2. Find an equation for the tangent line for f of x equals the secant of x at the point pi over 3, 2. So remember, when we're looking for the equation for the tangent line, the first thing we need to do is find the slope at that point. To find the slope, we're looking for the derivative at that point. And you're going to need your unit circle or your trig knowledge here. Both would also be helpful. The derivative of secant x is secant x tangent x. If you have no idea what else to do, at least take the derivative. At least you'll get points for that. Now we're trying to figure out the slope at this point. Remember that this point is x and then f of x. So I'm looking for f prime at pi over 3. So I need the secant of pi over 3 times the tangent of pi over 3. And this is going to give me the slope at pi over 3 too. Now, if you don't remember the secant of pi over 3 and the tangent of pi over 3, I hope you will at least remember the sine and the cosine at pi over 3. If you're looking at your unit circle, pi over 3 is about right here. This one is pi over 6. Remember that on the unit circle, the x coordinate of the point corresponds to the cosine value, and the y coordinate responds to the sine value. So in this case, for pi over 6, we know that the sine of pi over 6 is 30 degrees, or 1/2. The cosine is root 3 over 2. The square root of 3 is greater than 1. That makes sense. The x coordinate is further out on this point than it is in this one. At pi over 3, you have 1/2 and root 3 over 2. So your sine value is the y coordinate and the x coordinate is the cosine value. So you can rewrite this if you'd like as 1 over the cosine of pi over 3 times sine pi over 3 divided by the cosine of pi over 3. Sometimes I feel like I'm giving calc students a crash course in trig. All right, so go ahead and evaluate this derivative. The cosine of pi over 3 is the x coordinate, which is 1/2. So 1 divided by 1/2 times root 3 over 2 divided by 1/2. And you'll simplify this. 1 over 1/2 is 2. The square root of 3 divided by 1 is the square root of 3, and the 2's will cancel in the denominator. So your slope is actually going to be root 3 times 2, or just 2 root 3. Really, it basically is this. That is your slope at x equals pi over 3. Now that's part of the work. We have to still find an equation for the tangent line. Before I do that, does anyone have a question about the derivative or the slope? Terrific. Let's go ahead and set up our equation then. Y minus f of c equals f prime of c times x minus c. Sorry. So that's y minus f of pi over 3 equals f prime of pi over 3 times x minus pi over 3. This is not going to be the most simple, wonderful, beautiful equation you've ever written. Just do the best you can. I'm not going to be as picky about these. I just want you to solve for y. I already gave you f of pi over 3. The corresponding y value, it's up here. It's 2. F prime of pi over 3, we just found to be twice the square root of 3. X minus pi over 3. Now, to simplify this, I want you to solve for y and I want you to distribute, but if you don't have it all written as 2 terms, if you leave it as 3, that's fine. So this is okay with me. You don't have to combine these into one fraction. I used to force students to combine those into one fraction. But I realized that then it became more of an algebra question when they already had done all the calc. And I didn't really want to put that much focus on it. So this is fine. Now I have one more example for you, and I have a feeling. Yes, your web assigned questions will ask you for all places where this is true. We'll do that. Okay, questions here? All right, last example then. Example 3. Find all points where the tangent line is horizontal. The function is going to be f of x equals cosine x minus sine x. Remember that in order for us to have a horizontal tangent line, we're going to need the derivative to be set equal to 0, and then we're going to solve for the values of x where that occurs. So first things first, we're going to take the derivative f prime. The derivative of cosine x is negative sine x, and the derivative of sine x is cosine x. So there's your derivative. Now we're going to take your derivative and set it equal to 0 and solve for x. Now back in trig, you learned how to solve a bunch of trig equations. This one is a particular type of equation. It actually pops up quite a bit, but you don't usually solve it using regular methods. Normally, you just add one function to the other side. This is the way I usually see it anyway. And you ask yourself, where does the sine value have the opposite value as the cosine value? Well, in order to determine that, you first should figure out where cosine x equals sine x. Remember that when x is some variation of pi over 4, you're going to get the same value for sine and cosine. When you did it in trig, you rationalized the denominators and you got root 2 over 2. And this point was root 2 over 2, root 2 over 2. This means that at this point, sine x equals cosine x. Their coordinates are the same. However, as you move into other quadrants, you're going to find that there are some quadrants where those will have opposite values. Like, for instance, at 3 pi over 4, you are now at negative root 2 over 2, positive root 2 over 2. So this is a place where the where these two have opposite values. So the value of the sine is opposite the value of the cosine, or I should have said that backwards, but you catch my drift. In quadrants 3, they're both going to be negative. In quadrant 3, at 5 pi over 4, you'll have negative root 2 over 2, negative root 2 over 2, just because they're both below the x and y axes. And then at 7 pi over 4, the x coordinate will be positive, and the y coordinate will be negative. So when you're solving the equation sine x equals cosine x, or the negative variation for one of those, so negative sine x equals cos x, or negative cos x equals sine x, you're trying to figure out where their values are the opposite. So find where sine x and cosine x have opposite values. So if the equation was instead sine x equals cosine x, then you'd be looking at places where they have the same exact value, and that would be quadrants 1 and 3. In our case, we're talking about quadrants 2 and 4, because in quadrant 2, they have opposite signs, and in quadrant 4, they have opposite signs. So this is going to be quadrants 2 and 4. And we're going to generalize this. So when you were in trig, you learned how to give me all answers. Well, whoever your teacher was at the time. So you said that, okay, at 3 pi over 4, they're going to have opposite signs. But then if I added 2 pi to that, I have a coterminal angle where, again, they're going to have opposite values. And again, if I added another 2 pi to that, you're going to have a coterminal angle. So the way that you wrote that in trig, and by the way, we're going to make this a little bit more concise. So stay with me here. In quadrant 2, you would have told me that we have this angle in quadrant 2 where they have opposite signs. And we know that if we add 2 pi to that, they're still going to have opposite signs. And if we add 2 pi to that, they're still going to have opposite signs. So how you denoted that was you said plus 2 pi k, where k is an integer. And the reason you did that was because you could let k be 1, and then you'd just be adding 2 pi. You could let k be 2, and you'd be adding 2 pi twice. You could let k be negative 1, and you'd be subtracting 2 pi. See how that works? And you would have done something similar for quadrant 4. You would have said, okay, 7 pi over 4 plus 2 pi k, where k is an integer. And that would have also been true. However, when you have a case like this, where you're seeing that these values occur exactly pi apart, you can save yourself a little bit of work. And you can say that, all right, if I'm sitting here at 3 pi over 4, well, in this special case, the polar opposite of that is 7 pi over 4. So I can take 3 pi over 4, add pi, get to 7 pi over 4. I'll get to another answer. Add pi again, and I'll get back to this coterminal answer. Add pi again, and I'll be back here. So the way that we would write this more concisely, and I would say because these angles are polar opposites, take 1 and add pi k to it, not 2 pi k. You can always add pi k. Now, it technically doesn't matter which one you choose, but I would probably just say, take this angle 3 pi over 4 and add pi k to it. And this will give you every single place on that graph where you're going to have a horizontal tangent line. Now, I never, ever, ever faulted students if they wrote it like this instead, and they gave me 2 answers, adding 2 pi k. That's fine. The first one will always generate the quadrant 2 answer. The second one will always generate the quadrant 4 answer. This one is just more concise because you're taking 2 equations or 2 expressions and writing them using just 1 expression. So in this way, I can just always add or subtract pi and just get from one answer to the next. See what I'm saying? So officially, if you were asked to only find values in 0 to 2 pi, you would just tell me 3 pi over 4 and 7 pi over 4. If you're asked to find all points, which I asked you to do, I didn't say find only points in 0 to 2 pi, then you have to write it like this. So you're going to see 2 like this on your homework. Okay, I feel like there are probably questions on this. Who has a question for me? Anybody?
I'm kind of confused.
Okay. Which part specifically is bothering you?
So, you said like 3 pi over 4 and 7 pi over 4. Did you get them from the unit circle?
Yeah, so those are the places where the sine x and the cosine x had opposite values. So remember, the sine x is always the y coordinate, the cosine x is the x coordinate. So in this case, you would say that the sine of 3 pi over 4 is the opposite of the cosine of 3 pi over 4. They have the same absolute value, but they have different signs. And you could say it, I mean, you could say it backwards too. As long as you're just decoding the absolute value.
Aren't we looking for like negative sign? So, which is like negative y value. So wouldn't it be only just the fourth side of the wheel, the circle?
Well, remember, we could also divide both sides of this equation by -1, and then you would end up with this equation, which means exactly the same thing. So whether it's this one or that one, they just have to have opposite values. Sometimes it's easier to see this when they have the same value, saying, okay, where does sine x equal cosine x? And then do a different example where this happens. Because if it was sine x equals cosine x, you would be looking at these two places. And I feel like that's just easier to see. And then when you focus on where they have opposite values, you're looking at this situation.
Why did you pick 3 pi over 4
So
for the answer?
Oh, I had to pick one. It doesn't matter. This is the same exact thing as saying this. I mean, of course, k is an integer still. It's technically
Okay.
You could have chosen any angle. You could have chosen negative pi over 4, and then you could have always added pi to it. That would have been saying the exact same thing. That would also be, it should be technically correct in this case. They're really just odd integer multiples of pi over 4 plus pi k.
Okay, thank you.
You're welcome. I hope that clears up some confusion. But does anyone else have a question? Because sometimes for problems like this, where there are a lot of questions, it's the more people who ask, like just the more angles we hit on the concept. That was like a no pun intended. Okay, well, I'm done. I'm going to stay on here, though, until the end if you have questions. If you don't, that's fine. It's not like I'm going to judge you for leaving. I'm done. I'm going to put up some homework for 2-5, and it's going to follow these examples. And you might have a couple where you're asked to find a second derivative. I wouldn't expect there to be any issues there. I'm going to send an email with your asynchronous work to make so everyone should be clear on that. But I'll also put up a review assignment for you. If you have questions over the weekend, please feel free to send me an email. Sometimes it's hard to answer mathematically through WebAssign. So if there's really something you're stuck on and you don't get it, just tell me, like, I still don't get it, and I'll email you separately. maybe with some work attached or something if you're really stuck. But that's all. Test on Monday, 2-1 through 2-5. And I hope you have a wonderful, wonderful weekend.
All right, have a nice day, weekend.
You too. Thank you. I don't know if there are going to be a lot of questions if I should leave this recording. Might hold on to it for a minute.
Oh, I have a question. I just
Sure.
realized.
Go ahead.
I see the answer is 3 pi divided by 4 plus pi k. Why is it not 2 pi k? Just like on the
Well, you could include that, but this would only give you this point in quadrant 2 all the time.
all right.
If you add pi k to it, you're going to get both of these quadrant 2 and quadrant 4 points. Every time you add pi, you're swinging around. And that only works because these are polar opposites. So they're exactly pi apart.
Oh, okay. I get it now.
Yeah, but in a lot of cases, you do end up getting 2 separate expressions where you add 2 pi k.
All right. So for the answer, it'll just be 3 pi divided by 4 plus pi k.
In this instance, yes. I'm pretty sure, though, if you entered 2 expressions, that should be fine in WebAssign. This is just a nicer way of writing it, more concise.
Okay, I get it now.
Yeah.
All right, thanks.
You're welcome.
Have a good weekend.
You too. Thanks. What do you think, Griffin? Still stuck?
I think I'm getting it. If we have homework on this like tonight,
Mhm.
I'll see like how I'm doing. Cause this only like, cosine and sine, that's the only part that kind of like got me confused. But I wanted to ask you on the homework we had.
Mm-hmm. 2, 4.
Yes.
Okay.
So we did this actually like in the study time.
Oh, okay. There was one I went over and it wasn't clear.
Wait, which one was that? Hold on 1 second.
Okay. I did 16. No, I didn't. What did I? Yeah, I did 16, 6, and 17.
Oh, okay. So we did 32, and you gave me the points.
32. Was that today or was that last time?
No, it was today. I asked about the points of this function.
Yes. Sorry, I had 2 different notes and I mixed up which one was today. Okay.
Yeah. So you gave me the points of 0, 0, 0 for the smaller x value.
Yes.
And yeah, -3/2. It says it's wrong. Oh wait. What did you have for your function? Because I feel like I had the same function.
I think it was the same for everybody. X cubed divided by x plus 1.
Yeah. So for the points, it still says it's wrong. So I don't know why it says that.
Let me see. Mine says 0, 0 and -3/2, 27/4. Are you sure you entered it properly?
I mean, for the smaller x value, I did 0, 0.
Let me look at what you entered. Hold on, let me find it. How do you pronounce your last name, by the way?
Kaikjolu. Yeah.
I always wanted to ask that. All right, responses. Hold on, it's loading.
I'm taking your class again for fall.
Oh yeah, the Calc 2 class?
Yes, so
Yeah.
I picked your name again because like I thought it would be better, knowing you and continuing with it. So
Cool. Yeah, I have some spring students who will be in there too, so it should be a pretty fun class. Oh, it's because you switched the. You were supposed to enter the smaller one first, and the smaller x value is -3/2.
oh, so it's gonna be like the opposite.
Yeah, you just entered them in the wrong order. I know usually we think of 0 as being the smallest, but technically -3/2 is smaller. So try it again. Yeah, the fall Calc 2 class, it's super annoying because they had it on Monday, Wednesday, but I picked a hybrid class to teach on Monday, Wednesday. It was college algebra, and I only picked it because it was hybrid, and they wouldn't let me switch the days for Calc 2. So I wanted to do it fully synchronous, and they said, no, we're not going to switch the days. If you want to take the hybrid class, then you'll just have to teach them both half asynchronously. So it'll be like one night on and then one night off. Like, so I'll be teaching you guys synchronously on Wednesday, and then on that Monday you would have asynchronous work to do. I guess it wouldn't have to be Monday, but yeah.
You don't have classes on the campus? Because I saw like some classes had it on the campus. So
Yeah, so that's the thing. There might have been a Calc 2 that was hybrid that somebody already took, but I don't think there are any math classes that are fully in person. I think there are just hybrids, and there aren't even that many of them, which is why I picked up college algebra. I don't even like teaching college algebra, but I picked it up because it was one of the few hybrids they had, so I would at least get to go into campus one night a week.
yeah.
But you don't. That's the thing. You don't have the option to make it in person. Like, they give you the schedule and they say, okay, here's what we're offering. What do you want to teach? And at the time, the only Calc 2 class they had left was not hybrid. It was online only.
No, okay.
It's very frustrating, especially at this point, because it's just like, we're all adults. Most of us are vaccinated at this point.
Yes.
I mean, I got vaccinated a long time ago. I would love to
Me
teach.
too.
It's an experiment. Like, nobody wants to do this online.
I feel like it's even harder with math and like, you know, because I took history, I took speech class. That was a little hard, but I feel like it was better because we got to record the speech. Like, we didn't have to speak in front of everyone.
Yeah.
So that was a plus, I guess. But like, you know, it's easy to just like read or like, you know, write something, write your essay and stuff. That's fine.
Yeah.
But like classes like this, science classes, I feel like I prefer being in person too.
Yeah.
Yeah.